questions from the homework. Okay, so Kiara, number 2. Okay, these are the kinds of questions you're going to get on your test, but these are a little bit nastier in that there's lots of numbers. We have to kind of figure out what's going on. I find, for me, drawing a picture with that little normal curve and then saying, do I know the percentage? Did they give me the percentage? Am I above or below? Or read the question carefully. So it says, the Long Life Battery Company is planning to add another 10,500 batteries to the yearly production. I'm not going to use that yet. The mean life is estimated to be 50. Okay, probably over here somewhere, I would write down that. Standard deviation is 6. How many can be expected to last less than 31? I can't find how many. What I can find is what percent from the sheet. As a picture, what we're really saying is this. The curve looks like that, where the mean, which is always dead center, is 50. And we want less than 31. So 31, Kiara, would be like way over here somewhere. And we want less than 31, we want that area. The 1 second it takes me to draw that clears up so much of my confusion. And when I show you how to use, Adrian, your graphing calculators today, I'll show you how to get them to draw that picture so you can match your picture to your sketched picture, and that's one more way that you know you're right. Problem. My orange sheet doesn't have a 31 on it. My orange sheet needs an actual Z-score. So I need to find the Z-score that goes with 31. Oh, that's the other equation that we learned, x minus mu over the standard deviation, which I hope is somewhere on your page somewhere. I'm running out of room, so I'm just going to say the x-score 31 minus the actual mean divided by, what was the standard deviation, 6. This is my Z-score. Yoink. 31 take away, oh, hang on, menu, 1. 31 take away 50 divided by 6. I get a, wow, a Z-score of negative 3.16, negative 3.17 actually, if I round off properly. That's what I want to look up on my chart. Let's go find my Z-score chart. The orange sheet. Where do I have Z-scores? Under stats, under Z-score tables. You awake, Joel? What was it? Negative 3.17? Negative 3.0008. I always write that number on this little arrow that I've drawn pointing to the left, because again, I'm trying to get a routine and be able to recognize where I put stuff, so when I glance at it later, I'm like, that's where it came from. So what was it? 0.3 zeros and an 8. What is that as a percent? Careful, it's not 8%, it's actually 0.08%. Okay, now they want to know how many batteries? Well, it's going to be 0.08% of 10,500. What does of mean? Times. And I need to change this back to a decimal. It already has a decimal. No, it's a percentage. I know it has a decimal in the percentage, but it's a percentage. In fact, it's this number that I want to multiply by. Whatever the heck that is, I don't know. But whatever it is. It's going to be like, well, .4, I guess, because we can't really have 0.4 of a battery, 8 batteries. I think that's what it should say in the back. It might have rounded up to 9, but I don't think you would in this case. Yeah, that's pretty good. Very few. That means, you know what, they could probably offer that as a warranty if this was a company. They could say if your battery dies before 31 hours, we'll replace it for free, because 8 batteries out of 10,500, we can afford that. Before I take more questions, because there may be some. Can we turn, please, back one page to page 238 where we said pause here. Okay. Read example 4 to yourself, specifically as you're reading. What I want you to ask, and I know there's lots of words, is what the heck are they trying to get me to find? So, usually they ask the question somewhere in the last sentence, right, Adrian? You've done enough math word problems to clue in. That's where they ask the question. Adrian, what are they asking me to find in number 4? Read the question. The what? The what? The 2 words. Ignore the word the. Ignore the word determine. What are they asking me to find? Standard deviation. You know what, Adrian? They're asking me to find that thing. Write that down, because now it's no longer blank. I feel better. Now let's read the question very, very carefully. It was found that... Adrian, can you read to me from the start? Stop. You said percent. That's an area. In other words, that's one of these numbers here. In fact, somewhere over here, I think. But that's one of those numbers there, but as a decimal. With me so far? Keep reading. More than, you know what? Let's underline the word more than, because that's going to tell us what direction we're going on this curve. Above, to the right of 135. By the way, Emma, I'm trying to show you how I rip these apart, right? Phrase by phrase. Keep going. What that means is if they hadn't drawn the bell for me, I would draw the bell. Yes? Keep going. Ooh! What's the mean? Joel? So what we're saying is this number right here is 146, because the mean is always in the middle. On the standard normal, it's 0 and 1. This is not the standard normal. This is the real-life normal, but we're going to change it to z-score. Determine the standard deviation. So you say we did this. What other number did they give me, Adrian? This one here, 135. That's my X value. That's my actual score. Yeah? Very, very, that's tricky, by the way. Z is when it's a Z score, when the mean is 0 and the standard deviation is 1, or if they say standard normal distribution. X is what you actually measured out in the field, and that's really what I remember. I remember X is what we've measured out. This was your X value, or your foot length was your X value, or your height was your X value, or the length of the mass of the salmon is the X value. X is out in the field. Z is from the orange sheet. And the way I remember that part is on the orange sheet at the top, there is a little letter Z there. It's confusing. I know. And again, I told you guys at the beginning, and let me say this again. I am teaching this exactly like I used to teach this in Principles of Math 12, the academic, toughest math course. If you're finding this tough, you're normal. Relax. But not normal like bell-shaped, like normal. Like. Adrian, you see we have the 135 grams? Where would I put it on this curve? To the left of 146 or to the right of 146? That's why I put the mean on there. I'll put it right about there. It may be further left, it may be further right. I'm just doing a sketch so I can see. Oh, and remember the percentage? Can you find the percentage again, Adrian? Now, did it tell me that 62.3 were above 135 or below 135? Read the question. So what it's saying, I think, is that this area here was 0.623. See how we drew that? Okay, I filled in everything. What do they want me to find here? Jacob. You know what? I need one more thing. You know what I need? No, I don't need a Z-score because I live in Canada. A Z-score. Wow, really? You guys are... I've never seen this before. I thought we were proud Canadians. Yankees go home. Nikki, is that okay? Did you have or Colleen, did you have a question? I don't mind reclaiming. 62.3%. What's that as a decimal? Well, it's ready. It says this: 62.3% had a mass more than to the right of 135. What percent is to the right of 135? 62.3, or we always put it as a decimal because from here was a decimal. Right? Problem, Colleen. My chart doesn't give me areas to the right. My chart gives me the area or the percentage or the decimal to the left. I know this is 0.623, but what I really want is that, because that's what I need to look up on my chart. How can I figure out that? You hear? 1 minus. Can you do that on your calculator or in your head? How big is this area? If that's 0.623, how big is that? 1 minus, please. 0.377. Now, how does that help? If I find 0.377, I should be able to find a z-score that goes with it. 0.377, 0.377, yeah. I don't quite have a 0.377. I got a 0.3745 and a 0.3783. Which one's closer? Let's use that one, which is negative 0.31. Yeah? The z that goes with this is negative 0.31. The z that goes with this is negative 0.31. Sam, how's that help? Joel! See what happens when you do the homework? What was that? That just burst out of him. Knowledge bursting forth, wanting to see the light of day. I think just wanting to get out of his brain. Sorry? This is going to be, if we know 3, we know 4, we're going to use the z-score equation. You know what? Over here in the oh, I got it right here. Do you guys still have it on your page? We wrote it there? Oh, even better. Let's plug in everything that we know. So we can plug in negative 0.31 equals 135 minus 146 divided by, oh, that's what I'm trying to find. Joel, what am I going to do now? You already said it. I'm going to cross multiply. This is a little bit weird. Treat this as though it was a variable like an x or a y or something like that. In fact, if you wanted to, you could replace it with like a little letter y if you really wanted to. I'm going to keep it a sigma to get you used to using Greek letters. So I can deal with it. When we cross multiply, Joel, I think we'll get this. Negative 0.31 times the mystery standard deviation equals 135 minus 146. Yes, Nicole? You were zoning out. You with me? Oh, can you go on your calculator? What is that minus that? Sorry? Negative 11 equals negative 0.31 times that. Did I say times that, Alyssa? I did. How would I move the negative 0.31 over if it's timesing? What's the opposite of timesing? So let's try this again. Scene 1, Act 1, Take 2. How would I move the negative 0.31 over if it's timesing? The standard deviation is going to be negative 11 divided by negative 0.31. That's about as tough a question as I'll throw at you, and I'm not going to put 5 of these on your test. I'm probably going to put 1 where I give you the area and ask you to work backward, find the z that goes with it, Tanner, and then I'll either ask you to find x or that or that. I'll ask you to use the, if I know 3, I know 4. What is the answer, by the way? No, I didn't do it this time. Sorry. Negative 11 divided by negative 0.31. Standard deviation 35.5? Those are tough. Example 5. And if you're a bit lost on example 4, don't freak out. Like my grade 12s, even my honors grade 12 class, had a tough time with example 4. We'll practice it. And again, it's not the end of the world. I'm not putting 40 of these on your test. Example 5, I think, is a little easier. It says this: the marks of a large number of students have been represented on our standard curve. Oh, and Colleen, what's the mean here? That's why there's a Z, because this is our standard normal with a mean of 0 and a standard deviation of 1. The values given represent the number of kids in each area. How many are in the right half here? How many grand total do you think? Jacob, if half is 1250, I think there was a total of 2,500 that wrote this test or submitted this data. Is that okay, Nikki? Makes sense so far? Nikki, what does B want me to find? Z1. What I need is that area on my orange sheet, that percentage, that decimal. Do I have it? Not yet. Anybody think they can see how to do this? I'll pause, because every once in a while, when I was doing Math 12, I'd have a kid suddenly see it. Is that Twitch, Sam? How many kids from here to here? How many? Can someone add those together? Jacob? So this is here and here, 1,702 students. Out of how many? Out of if you get 80 out of 90 on a test, what percent is that? If you have 1,702 students out of 2,500, what percent is this? Or what decimal? Leave it as a decimal. Adrian, what'd you get? Could you? Nicole, what'd you get? My way of saying, follow along, boys and girls. It's also an easy way to help you pay attention if you haven't figured that out. Yeah. 0.6, I missed the last ones. 0.6808. So if I hear you, Sam, what you're saying is, as a decimal, this is 0.6808. What's the area this way then? Tanner, how can I figure it out? 1 minus. Can you find out what this area is, please? Page. 3192. Hey, is that on my orange sheet? Can I find a Z score? Because it wants me to find Z1. 3192, 3192, 3192, 313. Oh, bang on. Negative 0.47. Yes? That's also a tough question. Am I going to give you a bunch of those? No. That was kind of a continuation of where we left off. What I want to do for the next 20 minutes, 30 minutes now is show you shortcuts on your graphing calculators. So can you do me a favor? Can you get out the handout that I gave out last day, this one called Applications of the Normal Distribution? We're going to use this as some examples. Keep this handy, but then I have another handout as well. Keep your graphing yeah? I didn't miss you guys? You passed it down? Did I hand it to you? Give to you. 1, 2, 3. Okay. Guys? Shush. Thank you. Keep your graphing calculator handy. Using a graphing calculator, to me, this is what I'm going to be asking you lots of on your test. Something like example 1. It says, we can use the stat menu on our graphing calculator to calculate normal curve areas 2. Example 1 says this, a company manufactures batteries. From previous research, they know that their batteries have a mean life of 34.5 hours, a standard deviation of 4.2, and are normally distributed. What percent of the batteries will last between 28.5 and 38.5 hours? Method 1, by hand and by table. We're going to do this by hand and by table so that when we cheat and use our graphing calculator, we know we're right. What am I going to do? I'm going to do a little sketch. Yoink. According to this question, Emma, what's the mean? 34.5? So I think 28.5 would be over here somewhere. Yoink. 38.5 would be over here somewhere. Yoink. And we want the area between them. We want that. Can we find that, Sam? Not exactly. What we can find is, from our orange sheet, that area. We can also find that area. How will that help us to find the middle? We'll get a minus, bigger minus, smaller. Oh, problem. Sam already reached for his orange sheet. The problem is, does your orange sheet have a 28.5 or a, no? Oh, we need to change this, Colleen, to a Z score and another Z score. In fact, here's how I write this. I need to find the Z score that goes with 38.5, which is going to be x minus mu all over the standard deviation. Colleen, you asked a terrific question earlier. You said, how do I know which one's the x value? The actual measured value. You know what the actual measured value that we're trying to figure out is? 38.5 minus. What's the mean, Chelsea? 34.5 divided by, what was the standard deviation, Chelsea? I've scrolled down. Sorry? 4.2? What do you get for a Z score that matches 38.5? David? No, I just want the Z score. I don't want the area, just the Z. What does this work out to? 0.95? Anybody else? Yeah? 0.95 or 0.96? Round it off properly? Okay, we'll find the area in a second. While we're here, though, let's also find the Z score for 28.5, which is going to be 28.5 minus 34.5 divided by 4.2. It's going to be negative, I can tell you that. 28.5 minus 34.5 divided by 4.2. Do you get negative 1.43? Now, find the area that goes with 0.95 to the left of 0.95. Let's say this half of the room, can you find the 0.95? This half of the room, can you find the area that goes with, so this is 0.95, this is negative 1.43. Can you guys find the area that goes with negative 1.43? So this half of the room, what am I going to, and again, if you're not doing it this way, I find it really easy. I draw the line, write the line up here. What is the area to the left of 0.95, David? I heard the word 8. 2, 8, 9. Thank you. Or are you German saying no? No, 9. Okay. This half, Kayla, what did you get for the area to the left of negative 1.43? .0764. Is that right, folks? Okay. So, the probability that the battery X is between 28.5 and 38.5 less than. Remember, that's how we write an in-between statement. How can I use these two numbers to figure out the area in the middle? Subtract bigger minus smaller. What's the answer? Page. 0.7525, or 75.25%, which works great. Except, Melissa, how long did that take us? About 10 minutes-ish? Would you believe 5 seconds if you know how? And that's what I'm going to show you today. But we had to find the answer so that we know we're doing it right. So you ready? Option 2. So option 1 by hand. Option 2, choose menu, stat. Now we're going to change. Up until now, we've been doing most of our stuff under the calculations. This is called, listen closely, the normal distribution. So pick distribution, F5. Which distribution is this? Norm. And then you'll have to remember you want NCD, which stands for normal cumulative distribution. You want this one. Now your screen doesn't quite look like mine because it's not sure whether you want to use a list or the variables. We're always going to want to use variables. So you guys, I think, have to press F2, yes? And now your screen looks like mine, yes? Yeah? Okay. Hey, let me scroll up a little bit. What's the first category? What does it say right here? Sam, can you read that to me? It's asking, what's the lower value that you want? 28.5. You shouldn't. You might have hit something twice accidentally. Hang on. Hey, what do you think the upper value is? Look at our picture. 38.5. Down arrow. Or enter. Okay. Oh, what's this little, oh, that's the sigma, that's how your calculator does a sigma. That's the standard deviation. What was our, I've scrolled down. What was the standard deviation? 4.2. And what was the mean? And then you guys have a neater option than my free calculator. Does yours, if you go down to execute and highlight it, do you have a draw option called F5 or F6 or something like that? Hit that one. Yeah. Now, here's my question. Do you now see, Adrian, why I've been telling you to draw the picture? Does that on your screen match what we sketched? Yeah? Now, unfortunately, all I get is the calculated, all my calculator gives me are the numbers on the bottom of your drawn picture. Hey, what do you think Z low stands for? Is that the lower Z score that we calculated by hand? Yes, Rachel? What do you think Z high stands for? Or Z up? Is that the upper Z score that we calculated by hand? And what do you think the P stands for? That's the area between them. Now you'll notice though, it doesn't quite match ours. Why? This is more accurate. You're going to find, if you're using the calculator, your answer might be off with your neighbors if they did it by hand on the third or fourth decimal. The first two should match for sure. And you may notice if you're doing it by hand or by calculator, and my answer key, I did it the other way, you may start to notice from now on, Nikki, that you're good on the first 2 or 3 decimals, but on the third and fourth one, sometimes not. Is that faster than doing it by hand? Yes. Rob, you asked a great question. What was your question? How would I show? Okay. Anyways, there's the screen, and then here's walking you through it to get to this picture. What do you think Z low means? The lowest Z score. What do you think Z up means? The highest Z score. What do you think this means? The probability that we are between 28.5 and it was 38.5 was the other one, right? It's the area. Okay. You still have room on this page? How do I show work? If you choose to use your calculator, Tanner, you don't have to. Am I a nerd who likes technology? Will I probably do it? Yeah. Okay. This, Rob, is what I would need to see. If you press exit to go to this screen, you need to tell me what you wrote in the lower, the upper, the sigma, and the mean. In other words, what I would need to see is this. Lower equals 28.5. Upper equals 38.5. 4.2. Mean was 34.5. If you're using your calculator, if you write down that, I'll clue in, oh, you're choosing to use the technology. If you just write an answer without showing me what you've typed in, I have to take marks off because I have to assume you just cheated by boring up on it. Okay. So now that we know this, now turn the page. After one example. C. What percent of the batteries will last less than 30 hours? Quick sketch. Yoink. What was in the middle? What was the mean? Was it 32.5 or 34.5? Was it 34? That's what I wrote last time. Okay. 34.5. Tanner, where will this 30 be? To the left or to the right? Right there. And Tanner, what area am I going to color in? To the left of 30 or to the right of 30? Do they want less than 30 hours or more than 30 hours? Okay. Problem. Here's our first problem with technology. I can tell you what the highest value is. The highest we're going to get is 30. What's the lowest we're going to get? Okay. And the answer is negative infinity. Now, how do we type that? Can you see the upper value is 30 because we want everything to the left of 30? Right? Can you see the, what was sigma 4.2? 34.5. What I need to do is I need to type in a really big negative number because I can't type in negative infinity. So here's what we do. Negative 10 to the power of 99. Write that. That's, by the way, a 1 with 99 zeros, but negative. Is that a fairly big negative number, Shalon? A 1 with 99 zeros? Is it negative infinity? No. Is it close enough? So you ready? Negative 10. Where's my exponent button? Right here. To the power of 99. Now when I type that, my calculator is going to translate it to scientific notation. It's going to write it like, who cares? It makes it a negative 1e plus. Those of you that have used graphing calculators before will recognize that from science. What's my upper value? Oh, do I need to change my standard deviation or my mean? Okay, hit draw. Sadly, I can only hit calculate. You guys hit draw. Does your picture look like our sketch? Yeah? What is the area to the left of 30? Yeah? Yours doesn't work, doesn't... So can you press exit? Did you type -1 times 10 to the 99th? So -10 and 30? Upper value is 30, right? Is that okay? Yeah? Yours won't come up. Okay, hang on. Pause. Continue. What was the answer? 0.1, not 19, because what's next to the 9? And 0.1420, 14.2%. Okay. And again, if you use your calculator, this is what I need to see. By the way, you don't need to put the hat, although your calculator does. You can put a times or an exponent. You can write this as -10 to the 99th power if you want to write it that way, because that's what we're doing. Hey, what if we want the graph to go all the way to the left, we use a lower value of... That's our equivalent of negative infinity. A -1 with 99 zeros. D. What percent of the batteries will last longer than 40.2 hours? Quick sketch. There's 34.5. Rachel, where would 40.2 go? To the left or to the right of 34.5? Right here. Yoink. Rachel, do we want all of the batteries to the right of 40.2 or to the left of 40.2? Yeah, how do you know? What's the word that tells you that? Longer. Yeah, so right, I told you the other day, bigger, greater, longer, taller, words like that, right? Okay. I want that area. Nikki, what's the lowest number? What's my lower value in this diagram here? Think where we're starting. Where are we starting off? 40.2. What's my upper value, Nikki? Don't know. Oh, positive infinity, isn't it? Because it keeps going forever and ever and ever. So my upper value is going to be 10 to the 99th power. Standard deviation, 4.2. Mean, 34.5. Okay, can you find out what percent of the batteries will last longer than 40.2 hours? Yeah. Yeah, because isn't this way negative and this way positive? Good question. Yoink. 40.2, 10 to the 99th, the rest can stay. You get 0.0874? 0.0874, or 8.74%. So if we want to go all the way to the right, Zach, we use positive 10 to the 99th power. Is that okay? Let's do a couple more then really, really quickly. What percent of the batteries will last longer than 37 hours? Use your graphing calculator. Quick sketch. Boy, Nicole, what goes in the middle? What was the mean? Where's the 37 hours going to go? To the left or to the right? Over here somewhere, 37 hours. Yoink. Do I want to color in the area to the right of 37 or to the left of 37? To the right? What am I going to put for my lower value? What am I going to put for my upper value? Positive infinity. 10 to the 99th. Oh, the mean was, sorry, standard deviation was 4.2, mean 34.5. So Rob, this answers your question. That much work. And answer. You can write, if you really want to get nerdy, the probability that x is bigger than 37 is, and I'm good with that too. Yeah. Oh, I didn't change the values. What was my lower? 37? Upper stayed the same? 27.58? 0.2758? Yeah. Is that quicker, Adrian, than doing it by hand? I don't care which one you choose, because some people don't like technology. Try F and try G on your own, and let's see if we end up with the same as soon as we're done this. That's what I got for the first one. Double check me because I was typing this in a hurry. Again, Zach, make sure you're not copying. Make sure you can get this, right, kiddo? Good. By the way, you guys should be very impressed with that piece of technology. I would have killed for that when I was taking stats in high school. Because I did them all by hand. Is that what you got to? Yes, yes. You still do need to know how to find a z-score. If you know 3, you know 4, because the calculator doesn't do that for you, unfortunately. How many got that? Okay. Okay. Really, really quickly, just to show you how you can use this then, can you get out the, we're going to continue with part 2 of this lesson. Part 2 of this lesson is going to be, I'm going to also then show you how you can go backwards. Remember, we also on the orange chart got the area and found the z-score that went with it. It'll do that too. There's a procedure for that. We'll come to that. Can you get out that applications of the normal distribution sheet, this one here? Okay. Can you turn to number 3? How many of you have already finished question number 3? Only a couple? Would you like to do this by hand, or would you like to use the technology, Nicole? Okay. Photo radar, and if you don't think that the government works this out to figure out how much money they're going to make in their budget, you're nuts. Of course they do. They want to give you tickets. Please set up a photo radar station at Harris Road and Lougheed, because they know people speed there. From previous experience, they know the average driver travels at 88 kilometers an hour with a standard deviation of 12. If police set the photo radar gun to take a picture when the vehicle is traveling at or over 100 kilometers, what percent of the drivers will receive a ticket? Hey, let's do a sketch. Yoink. Kayla, what goes right here in the middle? 88. What's my cutoff value for the cops here? 100, that's going to go here. Do they want the number, the percent to the right or to the left? Now, did I need to tell you that we were going over, or could you have clued in that you only get a ticket if you're speeding, not going too slow? Okay. Anyways, I did tell you at or over. We want this area here. Come on, Pen. So the amount of work I expect to see, lower, upper, that, and that. What's my lower value going to be here, Jacob? What's my upper value going to be? Is this an in-betweener one? Nope, it goes off forever to the right. So positive infinity, yes. 10 to the 99th. What's the mean? What's the standard deviation? What's the mean? What percent of drivers can they expect to get a ticket? Give me the 4 decimals. Point what? 0.158. Is it 86 or 87? 87? Do you think they would round up? Yeah. They want the money. So they're expecting that many people to get a ticket? Oh, they also know that 6,000 drivers go past that intersection each day. How many tickets will they give out? We would like to find 15.87% of 6,000 drivers. What does of mean? Times, and make that a decimal. How many tickets will they give out? Round it off up or down, or properly? 952? Is that right? Ah, Rachel, now we're the provincial government doing our budget. Or maybe Pitt Meadows gets some of the money. I don't know how it all works. If each ticket's 180 bucks, how much money can the police expect to make every day? How many people get a ticket, Rachel? How much does each person pay? What am I going to do with those two numbers? Yep. If you ever wondered how they do some of these planning a budget a year in advance at the government level, this is some of the math that they would do. How much money will they make per day? I'm kind of curious myself. 180 times 952. I don't know how. I made up the 6,000. I don't know how many drivers go past Harris and Lougheed. Okay, Kayla, get rid of Harris and Lougheed and make it the Trans-Canada Highway heading into Vancouver. I'm willing to bet it's more than 6,000 drivers. I'm sure it's more than 6,000 drivers a day. Although, what happens as you get more traffic? What happens to how fast you can drive? Okay, then you get rush hour and things. So this isn't quite as simple as I've made it. We would have to take into account when there's more drivers, there's actually fewer speeders, strangely enough, because you can't go as fast. I don't know whether they run them 24/7, but this was one of the big gripes when photo radar was brought in about 15 years ago. We said this really looks an awful lot like a cash grab. I know for the longest time, for example, on Highway 1, they would put it on the hill just before the Port Mann, and you would see pictures of people with their brake lights on. They were trying to slow down on that steep hill, but because you don't hold your brakes the whole time, because that's hard on your brakes, you coast, you brake, you coast, you brake. They would get them when they were coasting. That was cheap. Because in fact, I think it's less safe to hold your brakes the whole time because that's hard on your brakes. Yeah. Yeah. Are you saying that you could do the quiz? Now, here's my question. On the quiz, what's the mean and the standard deviation? I didn't need to tell you because it's Z-scores. What's the mean? Yeah, you do. I heard it. 0. And what was the standard deviation for the standard normal? 1, because that was the simplest one. That's all that quiz is, all the z-scores. So you could use those. Yeah. I don't care. Oh, if you use the calculator, I will need to see some work. Right? The lower, upper, mean, sin. Okay. So, I have talked a lot, but I'm going to say to you, you can now do all of this sheet and probably know if you're right or not by comparing with the neighbor. Short sketch. Now, if there's questions where they're giving you the percentage, like number 7, like number 9, you can't quite do those yet because I haven't told you how to go backwards. Well, I'll give you a hint. Look up stat, dist, norm, inv norm. You can try and figure it out. It stands for inverse norm, going backwards. You can try and figure out how to use it yourself if you want to, but that's going to be Friday's lesson. Okay? There's 15 minutes left. Now, before I let Nicole go to the bathroom, I almost will, you can use your graphing calculator to do the take-home quiz, to do as many of the applications of the normal distribution as you can, and you can use them to do the lesson 5 homework, which many of you haven't done yet. Oh, the weird ones where they give you the area, a little trickier. I'm shutting up.